So my name is Abhi, and I'm a rising senior at St. Francis High School. And my project is the electromyography interface robotic arm. Now that is a lot of jargon, and I'll get into what that means in just a little bit. But I chose this project because one, I do robotics at school, and I thought it'd be a great extension to that. And then two, I wanted some sort of practical application, and I thought a biotech extension would be the perfect way to explore this. Okay, so now I'll get into a little bit about what the jargony phrase I said at the start really means. So the phrase was electromyographic interface robotic arm. So let's take it step by step. So robotic arm, pretty self-explanatory. Interface is a verb that can mean to interact with. So what exactly is a robotic arm interacting with? And electromyography can be divided into 3 different Greek words. So electro means electricity, myo is muscle, and graphy is just the Greek way of saying to write or to record. And so now we have a robotic arm that interfaces with or interacts with electricity that comes from muscles that we have a way to visualize or to record. And that's the essence of my project, more or less. And so I'll show you guys a demo video. It's about 10 seconds long. We'll watch it twice. So there's me flexing. I'll go over what every step means the second time around. But just so you guys get an idea, every time I flex, the robot does something specific. And so my project is made of 3 main components. So the white things on my skin, they're called electrodes. And their function is to take the bioelectrical inputs that are given from my muscles and convert those into electrical signals. And then that's sent to the red sensor that's connected to my skin tube. That's called the electromyography sensor, or the EMG sensor for short. And this sensor is in charge of receiving those electrical signals and amplifying them, and then sending them to the Arduino for processing. And you're going to hear Arduino thrown out a lot today, but basically it's like the brain of the operation. So think of it as like the main center that controls everything. And so 3 parts. We collect the bioelectrical signal, we convert it to electrical signals, then we send it to the brain of the operation that then decides what to do with that input and output it as a physical manifestation in the robotic arm. And so in terms of challenges, I would divide them into 2 major sectors. They were electrical and mechanical. So in terms of my mechanical challenges, you'll also hear servos being thrown a lot today, and that word is basically a reference to these blue things on the arm, or for any project for that matter. And servos are basically like joints in the human body. They're responsible for mobility. And when a servo is broken, it restricts the mobility of that particular device. So similar to how if one of our joints didn't work, we wouldn't be able to move as we do move today. And so that's why you need to make sure that your servos are in place and in proper working condition, because if they're not, then your robot isn't going to move as per plan. And so I had to troubleshoot whenever my servos didn't work, and a couple of times the servos stuttered or they just completely stopped functioning, so I had to replace them. And so that's a really important thing to note. You have to make sure all your servos, or all my 4 servos in this particular case, worked at every given point in time. And the second electrical issue I had was that my input current stream that was responsible from this sensor right here, the red sensor, it wasn't constant at one point. So I had to figure out a way to make it very consistent. And so basically what's happening is that the light on the sensor, it turns on every time it's given an input. And it used to flicker, which meant that it got input, but at an inconsistent rate. And so that caused my robotic arm to be choppy, because it only got input every other second from every other flicker. And so those are my 2 main challenges. I'm still working on that second challenge today. In terms of my extensions of the project, as you guys saw in the video, when I flex, it only has 1 range of motion. It only actually moved from one of the joints. So it lurches forward, grabs something, and then comes back. So one of the extensions I wanted to add was to make it mobile from the other servos or the other joints. So maybe when I curve my arm in a certain way, or do another type of contracting with my muscle, another type of motion, it would result in the output being slightly different. And aside from that, in terms of what I learned out of this thing, I would also divide that into 2 categories. They would be, so the first one would be electrical components, because I do robotics at school, and so I had knowledge in mechanical mostly. So I do CAD, and I use CNCs, and I'm mostly in charge of the mechanical parts. So the electrical components were completely new to me, as is with a lot of my peers today, I think too. And so that was a great experience for me overall.